Welcome to another exciting geometry lesson. So, why was the obtuse angle so sweaty? Because it was over 90 degrees. What a fantastic joke. Alright, 4.2, congruent polygons. So, we've learned about that word congruent before. With angles it means equal measure, with sides it means equal length. Well, with polygons, if they're congruent, that means that all of the sides and angles of one figure are congruent to all the corresponding sides and angles of another figure. So this would be an example of congruent triangles. We see that angle A is congruent to angle F, angle B is congruent to angle E, angle C is congruent to angle D, and then our segments, segment AB is congruent to segment FE, segment BC is congruent to segment ED, and segment AC is congruent to segment FD. All those parts are congruent, so we say we have congruent triangles. We'll spend a ton of time talking about congruent triangles. Next we have what are called congruent statements. So to say you have congruent triangles, we're going to use the triangle symbol, which is a triangle, and then we use the letters. Now, it does matter what order you put these letters in. So, for instance, you can say triangle ABC is congruent to triangle FED. Apparently it didn't let me put my other triangle symbol there, but there should be a triangle symbol there. And the reason that we say it in this order, well, A, since it's the first letter, should be congruent to F, since that's the first letter. So A and F, we see that they're the same. B and E are the second letters. Again, they match. And then C and D also match. You could also say this one here. Triangle BCA is congruent to triangle EDF because, again, B and E match, C and D match, A and F match. However, this one at the bottom does not work. You can't say that triangle ABC is congruent to triangle EDF because if you see A and E are both in that first spot, but the problem with that is A and E are not congruent. So make sure when you're writing a congruent statement, that's what these are, that your letters are in their corresponding or matching spots. So an example here says, what are the corresponding corresponding parts? Well, our parts are the angles and the segments. So angle A is congruent to angle, well, if we compare pictures, A and F. Then we can say angle B is congruent to angle E. And then so angle C is congruent to angle D. Then we got our segments. So AB is congruent to, well, we got one dash and one dash. AB, so one arc to two arcs, so we're going to go FE. Then we can say segment BC, 2 and 3 is going to be congruent to ED. And then finally, segment CA is congruent to segment DF. I feel like this board is not connected very well. That frightens me. Oh well. What congruent statements can you make? Now, when I'm writing a congruent statement, I like to pick out one of my triangles, so this one, and put my letters in any order. So let's say I want to go triangle BCA. So then the second triangle is dependent on which order you put these in. So I got to go, okay, which one matches B? That's E, so E comes first here. Which one corresponds with C? So that's going to be D. And then which one corresponds with A? That is F. And again, there's another way you could do it. You could say ABC is congruent to FED. That would work as well. Just make sure that your letters are matching the corresponding angles or segments. All right, in the diagram, polygon ABCD is congruent to polygon FGHK. We want to find x, we want to find y. So, if we look at x, well, we have an x here. We also have an x over here. The 3x minus 6, we have f and g. FG, now you can tell in the picture it's going to match AB, but it's not always that obvious. But FG, first 2, so that should match first 2, which is 21. So then we can say 3x minus 6 equals 21. So 3x equals 27. X is going to be 9. Then if we want to find y, well, we're going to look at k. K is the last letter, so k should be congruent to d. So that one right there. So we can say that 4, well, x we know is 9, plus 2y equals 44. 36 plus 2y equals 44. And so 2y equals 8. And y is 4. So again, to figure out which ones to set congruent or equal, you can use these congruent statements, okay? Because you know, for instance, that angle A and angle F are the same, angle B and angle G are the same, and so on. Same can be said, AB is going to be the same as FG, BC is going to be the same as GH, CD is going to be the same as HK, and so on. So those congruent statements are useful in that they can tell you which parts are congruent, as long as they're written correctly, which is also why we got to write them in the correct order. This is our third angles theorem, so make sure you have this written down prior to coming to class. It says if two angles of one triangle are congruent to two angles of another triangle, so here, angles B and angle A are congruent to angles B and angle D, then the third angles are also congruent. So angle F has to be congruent to C. So that's your third angles theorem. And that one should be a fairly easy proof. The way you would prove that would be, you can say that, measure of A plus B plus C equals 180. Measure of D plus E plus F equals 180. Then use your transitive property. So you would have angle A plus B plus C equals angle D plus E plus F. Then you can switch your C to F, for example. Subtract F to both sides. Well, actually, sorry, that's the end part. You can change your A to D, and you can change your B to E, and then subtract those off, and get left with the C in the end. Is how you would prove that. Can't remember if I assigned you that proof or not. I think I may have. All right, this example. Find the measure of angle BED. Well, here we got two triangles. This one, and this one. Well, those segments. And then we got this triangle here. Now, if you notice, we have 45 and 45. And then we have 30 and 30. So that third angle we're going to be looking at is going to be this one. And if we're finding BED, that's one we need to have. Well, if we have 30 and 30, triangles add up to 180. So that makes this angle 120. These are vertical angles, so those should be equal. So those would be 30 and 30. $180 minus 30 minus 45 is going to be 105, and then you add the 30 and the 105, and you get 135 degrees. And just one last example. This one's got some trickier algebra in it, so that's why we're going over it. Got to solve for x and y. Well, we have another 90 here, and we got these two. Well, that tells us straight up that 4x plus 2y equals 56, so let's write that. Then we got one equation. We should know what this angle is. 180 minus 90 minus 56 is 34 degrees. We can use that third angle theorem, because these are congruent, so these two would be congruent. We can say 6x plus y equals 34. Two ways to do this. You can use substitution. So you can subtract the 6 over. Actually, let's do it that way. You could use elimination if you remember that, but you got to multiply this one by 2, then subtract. But let's use substitution. We're a little more familiar with that. So I can say y equals 34 minus 6x by just simply moving that over. Then I can take this sucker here and plug it in for y, because this equals y. So then I would have 4x plus 2, parentheses 34 minus 6x equals 56. So 4x plus 68 minus 12x equals 56. Combine your like terms. Negative 8x. And let's just subtract that 68. So 56 minus 68 is negative 12. And then divide by negative 8. And we get 1.5, which it would be better to write 3 over 2. And then we take that and we can plug it into one of these guys up here. So 6 times 1.5 plus y equals 34. 6 times 1.5 is 9. And then, subtract your 9, and y is 25. You can bet I'm going to want you to show work on that one. All right, there's your assignment. Again, feel free to start early if you would like. Otherwise, plan on coming to class ready to roll.